Okay, so right, these four formulas are everything that we do in this section of the course. You're just using these to solve motion problems. When we're dealing with constant acceleration, you will always be given constant acceleration. If you don't have constant acceleration, you have to use calculus, and that is not at our level. We're not going to do that. You have to have a constant acceleration, and I'm not going to trick you. You will either have an acceleration or you won't. Okay. So we did some questions. We did this first question. We did part A, finding the acceleration. This was exactly like the basic motion warm-up. Use our formula. We've got our values. We can just solve for acceleration, 1.2 meters per second squared. I got you to do B on your own. I told you it was 10.6. Again, the only thing is you're slowing down, which means your acceleration is negative because you're slowing down. Other than that, these questions are like very, very similar, very straightforward. Okay. We did this ball rolling question, right? Where we have an initial velocity of 0 starting from rest. We can use the same formula. We've got an acceleration. It's beautiful. If you are ever asked to find distance while accelerating, go to this third equation, right? This holy grail, that initial velocity term cancels out and just leaves you with a nice x equals 1/2 at squared. Really, really nice formula. Okay. So number 3 and 4, I asked you to try, right? So we're going to do these ones together. Well, I won't go into too much detail, but here, this first number 3, we've got an airplane that must reach a speed of 110 kilometers an hour before taking off. The plane accelerates at 2 meters per second squared on a runway that's 150 meters long. Will the plane be able to take off? Reach the required speed to take off? I love these types of questions because I'm not asking you to solve for something. I'm asking you to solve a problem. And there's a couple different ways that you can do this. If we have a runway, right, that looks like this, and we've got this plane. I'm really good at drawing planes. We have this plane doing this, right? We know, oh shoot, go on. Okay, we know a couple things about this. We know that the initial velocity is equal to 0, and we know that the acceleration is 2 meters per second squared. But we also know that we need a final velocity of 110 kilometers an hour, which if we go ahead and just convert that to meters per second, 110 divided by 3.6 is 30.6 meters per second. And we know that we have a distance of 150 meters to do this. So there are 2 different ways of doing this question. The first way is you can ask yourself, how much distance does the plane need to reach a final velocity of 30.6 meters per second? That's the first way of doing it, okay? We ignore the fact that we have 150 meters for now. We say, okay, we're accelerating, we need to reach this speed. How long does it take to do it? Can we do it in under 150 or do we not, right? The second way to do it, I'll use a different color, I'll use purple, is to ask ourselves, in 150 meters, how fast do we get? Right? Same question, 2 different ways of doing this. And in this case, right, in our second case, we ignore our V final. We don't use this. We want to see, okay, we've got 150 meters. We accelerate at 2 meters per second. How fast are we ending up? Okay. Doesn't matter to me which one you do. Somebody pick in the chat. Somebody pick. Do you want to do the first way or do you want to do the second way? Whoever says a way first. 2. Okay, beautiful. Ooh, resounding 2. Fantastic. So in 150 meters, how fast do we get? Beautiful. So we don't know anything about time, but we have a distance and we have an acceleration. So we can know our v final squared is equal to v squared plus 2ad, since there's no time given. Okay. We know we start from rest. That's fantastic, which means 2 times 2 times 150 v final squared. Oh, we should just take the square root of that. That's totally fine. So according to this, our final velocity, do I have this? Where is my note? There we go. We get 24.5 meters per second. Okay. What does that tell us? Well, it tells us that I ran out of room, but it tells us that that is not fast enough, right? We needed 30.6 meters per second to take off. So this plane does not actually work out. It can't take off on this 150-meter runway. Try this one on your own. Try the first way on your own. You're going to get the same answer, right? You're going to get that this plane does not have enough room to take off. So try it. Okay, cool. Good. Cool. Question number 4. During a street race, right? Car's accelerating from rest, 3.5 meters per second. How long does it take the car to travel 100 meters? Okay, this seems fun. We're given some information here. Starts at rest, so our initial velocity is 0 meters per second. We're given an acceleration of 3.5 meters per second squared. We're given a distance. This car is going to travel 100 meters, and it wants to know how long is that going to take. So how I go through these process, like when I get a question, this is my first step. Write down my information. What do I have? What's given? Okay. I'm looking for time. I have some speeds, an acceleration, and a distance. So if I look back up at my formulas, okay, I'm looking for time. So number 4, not really that useful because there's no time there. Okay. Distance, time, velocity, we have an acceleration, so that one's not awesome. What about this one, number 2? Well, there's no distance. We're given a distance. We need to use that distance somehow. So that one is not helpful. So automatically, number 3, the holy grail, because we're starting from rest, it's a beautiful equation to use. So we can go ahead and say, all right, well, our x, our distance, is going to be VIT plus 1/2 AT squared. There's our holy grail. We're starting from rest, so that goes to 0. So our distance is just going to be 1/2 AT squared. And now this is just algebra, right? You remember last week when we did math physics and I was making you do algebra? Hey, look, you've done this algebra before. We want the time. 2 times x is equal to AT squared, which means t is going to be 2x over a, all square rooted. Let's just plug in our numbers. 2 times 100, all divided by 3.5 square root. Now, technically, we have plus or minus, plus or minus. So technically, when we find this time, we find that we're going to get a plus or minus 7.6 seconds. But do we really need to put that negative in there, right? Does that make any sense at all, right? There's no negative time. So there's really no point in even writing the negative. You don't have to do it. You can literally just say it's 7.6 seconds. That's as much as you have to do. Okay. Thank you, Noah, for agreeing with me. Nah, no negative times. Okay. If you get negative time, that's not good. Okay. That means you did the question wrong. Cool. Two nice examples, right? This is all this is. I love these questions. These are like little puzzles to do. They're so much fun. Um, so number three, number four, then we did together number five. This question is more involved when you have reaction time. Watch the video of me doing this question so you can walk through it. Pretty much all that's happening here, you've got a distance that you're traveling while you're reacting, and then you have a distance you're traveling while you're slowing down. And if it tells you that the deer is 50 meters ahead of the car, then you have 50 meters to stop. So you need to figure out how far did you travel before you started braking, and then how far did you travel while you stopped? And in this case, the deer was saved. This question can look, I can change this question up a whole bunch of different ways just by giving you different information and asking for something else. So for example, I could say, hey, this deer is 50 meters about in front of you. What is the longest reaction time that you can have? Like how before you actually hit the deer, in which case you just have to work backwards a little bit and know, okay, you're going to travel 36.7 meters while you stop, which means you have the difference between 36.7 to 50 meters in order to react. So how long, if you're traveling at a speed of 25 meters per second, how long does it take you to go that distance to react? Okay, same question. That's just one example of me flipping it. But whenever you kind of hear reaction time, stopping distance, stuff like that, you should think about this idea of a reaction time distance and a stopping distance. Okay. Cool. And so that's kind of level one questions, or the first type of questions. The other types of questions that I put a video on are free fall questions. And these are super fun because they're exactly the same. The formulas are the same. Everything is exactly the same. But when you're going up and down vertically, you have an acceleration always. Everybody pick something up in front of you, a pencil, a marker, a little whatever, just not your phone or your computer. Just pick something up and then drop it. Pick something up and then drop it. Let's do it again. We drop it. What's happening? Are things falling down? Did you hurt yourself? Probably. It's gravity. Okay, I'm ignoring the chat for now. Right, that is gravity. That is an acceleration that is always there when you're working with vertical motion. So your acceleration is always negative 9.81. It must be negative because it's going down. The questions are not going to tell you what gravity is. You need to be able to recognize in your head, oh, this question's going vertical. I'm throwing a ball up in the air. That means I have a negative acceleration. I have gravity. Okay. Our kinematic equations are exactly the same, but all we do is just replace some of the letters, right? Instead of x, we're dealing with y or height, right? I like to use either one, height or h or y. You can replace the acceleration with gravity if you want. I don't really, I just kind of plug it in after, but if you want just to remind yourself that you know what it is, then that's totally cool too. Same equations, everything else is exactly the same. The only other important aspect of a free fall question is that when you are at a maximum height, your velocity is zero. Your vertical velocity is zero. And what that means, if you think about me throwing this marker up, okay? I throw this marker up, stops, and then it falls back down, right? Throw it up, down. You can see, and if you do it right in front of you, throw it up and stop, you can see right at the top of the motion, this marker stops for a split second, okay? That means that the velocity there is zero in the y direction, so we can use that to split up, okay, well, how long did it take to go up? How long did it take to go down? We can use that as a final velocity being zero or an initial velocity being zero. Whatever it is, you can use that maximum height to your advantage in order to figure out where like some time, distance, anything like that, okay? Those are kind of the two keys when it comes to free fall motion that are not going to be stated specifically in the question, okay? So I did this bungee jumper question. where we wanted to figure out velocity. You jump off a bridge, how fast are they going after the free fall? So really, all this question is, I could say a car is accelerating at 9.81 meters per second squared for 2.2 seconds. How fast are they going? We can do that. That's just a basic motion problem, except with this gravity as acceleration. You're going to get a negative in there. That negative means its motion is now downwards. That's totally cool. Okay. Same thing with distance, right? We literally just did this question about figuring out how far does it go when you accelerate. If we look back, where was this question? Nope. This one. How far does we have a ball starting from rest and accelerating at 3 meters per second? How far does it go in 4 seconds? Okay. We use the formula. The question that we're looking at right now is exactly the same as that question, except we're falling downwards. So we have a height and our acceleration is negative 9.81, the exact same question. Okay, free fall questions are no different. So the only thing to be like, you do have to be careful because I could change things up and I can ask you stuff about different planets, right? This question, what's the acceleration due to gravity on the moon, right? I'm asking you, what is acceleration or g on the moon? Okay, so it's no longer 9.81. That's just a little hint. It's not negative 9.81 meters per second squared. We need to find that. So I'm giving you a height. I'm giving you a time. So let's figure out where should we go with this? We've got here is an initial height of 1.29 meters. And we've got our final height of 0 meters, okay? And it takes a time of 1.29 seconds. With free fall questions, oh, stop it. There we go. Just be careful. If you are falling down, you are losing height. Your change in height is negative. If you think about your change in height being final minus initial, your final height is 0, your initial height is negative 1.29, which means your delta H is negative 1.29 meters since you are going down. That's a key point when it comes to free fall questions because you're losing height. But once you have your height and your time, 1.37, oh my goodness, it totally is. Thank you. I can't read. Reading is hard. 37. And if those of you who've had me as a teacher before, you know I can't do math either. So I can't read, I can't do math. I don't really know why I'm here, but that's okay. We're having fun. So we know our change in height, VIYT plus 1/2 AT squared. You can get to the point, if you are comfortable with this stuff, you don't even have to write this initial velocity. If you know it's starting from rest, that's totally cool. Just get rid of it. Delta H is equal to 1/2 AT squared. We are solving for acceleration, so we need to multiply by 2 and divide by our time squared. Plug in our numbers. 2, negative 1.37, all divided by 1.29 squared. And you should get an acceleration of, drum roll please, negative 1.65 meters per second. That negative is super important because it means it's going down. Okay, so super important that you used a delta H of negative. Okay, cool. That's free fall question. It's lovely. It's so lovely. Are we good? I'm going to pause here for 2 seconds. Do you have any questions or anything? I'm going to make a quick little poll. Zoom will show me my thing. Come on, Zoom. Poll, edit. How do you feel? Okay. Here's a poll just to check in, see how you're all feeling with these types of questions. Not just free fall questions, but like all the constant acceleration type questions. Okay, good to know. Cool. These are like slightly challenging questions. They are kind of a little bit out there. The only way to get better is to practice. And the good news with these questions is you have so much practice. You have a ridiculous amount of practice when it comes to these questions. So what we'll do one more question together. Um, we'll do one more question together and then we'll stop for the day. And then you can watch this video again, you can watch the videos on YouTube, and you can practice them. I'll show you a link after or this. So if you go to the bottom of the notes, if you take your phone and you scan that QR code with your camera or with Snapchat, or just click and go to that website, there are probably like 20 or 30, a ridiculous number of worked out kinematic questions with solutions. They're beautiful, they're fantastic. You can go there for lots of awesome practice. I will also put questions on Nexus. You'll probably get like, in total, you'll probably have like 100 practice questions. So you gotta do it more and more and more, which is nice for this. Okay. So we'll do this question, we'll stop, and then we'll come back tomorrow. I'll make videos for these last 3 questions, and then we'll just go through them tomorrow. Hopefully, if you have a day today to just kind of relax and do some questions, it'll be okay. So we've got a ball being thrown straight up. So here's a pen going straight up, okay, with an initial velocity of 8 meters per second. So it's going up at 8 meters per second, coming to a maximum height, and then falling right back down. So we want to know what's the maximum height, how long does it take to reach the maximum height, and how long until the ball lands back in your hand, okay? So step 1, maximum height. Remember, whenever you read maximum height, you should think velocity is 0 at the top of the motion, okay? Maximum height, 0 velocity at the top. That should be like a boop, 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 boop right in your brain. Which means if we have an initial velocity of upwards at 8 meters per second, we're going to get a final velocity of 0 meters per second. Oh, it's frozen again. Thank you. I'm just testing you to see if you're actually paying attention. And I just see, so someone else at formula sheet, seems how, so if this was a real class, you'd get a formula sheet. Since this is not a real class and I can't stop you from looking at your notes or anything, I am not going to provide you with a formula sheet, because you have all your notes and everything. Because I've never once said don't use your notes for stuff, right? Because I can't actually police that. So no, you will not get a formula sheet because you get your notes. Pretty good trade-off, I think. Okay, you see this? This is good? Good stuff. So initial velocity, final velocity, and we want to know what is the maximum height? Okay, h max. We have nothing to do with time. So let's just write down our formula. V final squared is equal to VI squared plus 2A, I'll call it delta H, okay? That one has nothing to do with time. So can we use it? Well, let's look at it a little bit closer. Our final velocity is 0, so that's 0. We know what our initial velocity is, and we know our acceleration, and we want our height, so this is good. We can use this formula. We can bring the initial velocity over, so negative vi squared is equal to 2a delta h. Divide by 2a, so delta h is going to be negative vi squared over 2a, which means we punch in our numbers, negative 8 squared over 2 times negative 8.1. Those two negatives are going to cancel each other out. And what you're going to get is a beautiful number of 29.4 meters. Okay, positive because we are changing from 0 up to our final height. If you want, right, technically this is equal to final minus initial, but our initial height was 0 since it's on the ground. Okay, and it makes sense. Your change in height is going a positive from down here and up. Okay, you're gaining height. So cool. 29.4 meters up in the air. Now we want to know, how long does it take for this ball to reach its maximum height? Now, there is a couple of different ways we could do this. You might think, okay, how long, and we have a distance. So you might want to use the Holy Grail, but I'm going to write this down. You don't have to write this down if you're following along, right? This formula, since we have an initial velocity of 8, this formula gets kind of gross. So if we have an initial velocity, we don't really want to use this, okay? Instead, we want to think, okay, well, what do we have? Since we're only going to the maximum height, we know our initial velocity is 8 meters per second, and our final velocity is 0. We know our acceleration. So all this is saying is, well, how long does it take for gravity to slow this ball down? We've got a nice formula, V final is equal to V initial plus AT. This is a nice, easy formula. Our acceleration is gravity. We know that. We know everything else. So let's go ahead and solve this formula. We're going to get negative VI equals AT. So T is equal to negative VI over acceleration, which is negative 8 over negative 9.81. You see how if you forgot the negative with gravity, that you'd get a negative time, and that would just be scary. So that negative is super important that we take that into consideration. Okay. So we go up there. So we've got our initial velocity. Wait a second. I might have made a mistake. Freeze for a second. 8 squared. This answer sorry, I'm copying off answers that I did last year, but I realized I made a mistake last year. This should not be 29.4. If you actually punch this in, you are going to get 3.3 meters. So sorry about that. You should have got 3.3 meters with that 8 meters per second initial velocity, okay? Everything else is the same, I just used the wrong number, okay? Which means if you punch this in for the second point, part B, 8 divided by 9.81, you get 0.82 seconds, okay? So it takes just less than a second for this ball to go up and stop, okay? With me so far? Feeling okay? Having fun? Doing great things? Now, there's a really cool thing about free fall. If we want to know how far it takes for the ball to land back in your hand, well, if we draw a picture, okay, here's my hand. This ball is going to go up for 0.82 seconds. The acceleration is gravity. Gravity doesn't change. How long do you think it's going to take to go right back down? Right? If it like how long? It goes up and then back down. The same acceleration acting on it, nothing else has changed. Goes up and then it goes back down. Do you think there's going to be any difference? Yeah, 0.82, right? It's going to be 0.82 seconds up and it's going to be 0.82 seconds down. Okay. As long as you're starting and ending in the same spot, the time up is going to be exactly the same as the time down. And you can do the math if you really wanted to. Right on one side, I'm going to move this over here. On one side, you have an initial velocity of 8 and a final velocity of 0. But on the other side, you have an initial velocity of 0 and a final velocity of 8 meters per second. Because this thing is just, it's going to be moving exactly the same speed that it is going down because nothing else is acting on it than gravity. Gravity is acting on the exact same amount of time. Okay, because right, the change in height here is going to be 3.3 meters, and then the change in height over here is just going to be negative 3.3 meters. Goes up 3.3, down 3.3. Okay, takes 0.8 seconds to go up, takes 0.8 seconds to go down. Goes up at 8 meters per second, stops, starts at 0, goes down, is going 8 meters per second. They're very symmetrical like that. Okay, so they're use that symmetry. It's going to take exactly the same amount of time, 0.82 seconds, to go right back down. If I asked you, how long does it take for the ball to hit the ground? Now that question's different because now you're starting from this point, you're going up, but then you're coming all the way down to the ground. So the question looks a little bit different. So just be careful about the wording there. And cool, that is another type of these questions.